Let me take this opportunity and welcome you to my YouTube channel. Before I start with today's lesson, I would like to ask you to please subscribe to my channel. Then on today's lesson, we are going to look at magnetic declination. What is magnetic declination? Magnetic declination is the angle between true north and magnetic north. So what you need to understand about magnetic declination, secondly, is that magnetic declination changes yearly, and it must be calculated because it changes yearly. The reason we calculate magnetic declination is because we want to get the position of the true north. Information to calculate magnetic declination can be found on the map. When it comes to the issue of magnetic declination changing yearly, what you need to understand about that is that magnetic declination change in two directions. When the change is westerly, the magnetic declination will increase. That's why we add when change is westerly, because magnetic declination increases. When the change is easterly, the magnetic declination will decrease. So if the change is easterly, then we will have to subtract. Then let's consider the following example when it comes to calculating magnetic declination. Let's take we are given the following information. Question says, calculate the magnetic declination for the current year. Remember, I said the information that you can use to calculate magnetic declination, you will get it on the map. When you get this information on the map, it will be written in this manner. For example, in this case, mid-magnetic declination is 26 degrees, 31 minutes west of true north. And this was for June 2011. Then mean annual change is 6 minutes westwards. And then now we must calculate the magnetic declination for the current year. In order to do that, how do we start? We start by determining the difference in years. To do that, we must start by determining the difference in years. Then when we determine the difference in years, we will be able to determine the change. Firstly, we start by determining the difference in years, right? Then when we determine the difference in years, the current year is 2024. Then we are going to have 2024 minus 2011. And this will give us how much? It will give us 13 years. So it means that the difference in years from 2011 up to 2024, we are getting 13 years. Then after determining the difference in years, we then determine the total change. How do we get the total change? To get the total change, remember from the given information, they said the change you can see there, the change is 6 minutes westwards. So now to get the total change, we take the difference in years, which is 13 years, and we multiply it by the change annually, the mean annual change annual, which is 6 minutes. which is 6 minutes westwards. And then when we take this and multiply 13 times 6, we are going to get 78 minutes. Remember, the change is westwards. So it means that we are going to get 78 minutes westwards. And then now we have the change, right? The total change. We have the total change. Then lastly, we add the total change from the given information. We then add the total change. Then to add the total change from the given information, we were given that in 2011 the mean magnetic declination was 26 degrees 31 minutes, right? Then now we add the total change for the past 13 years. Then it will be plus 78 minutes, right? Then when we add this, we are going to add the minutes because we are having minutes there. Then this side is 26 degrees 31 minutes. We are adding the 78 minutes. 78 minutes plus 31 minutes. This will give us what? 26 degrees. But the minutes, we are going to have 26 degrees. But the minutes will be 109 minutes. And then remember this information. I'm going to write it from the side, this side. Remember that 1 degrees, it's equals to 60 minutes. So because 1 degrees, it's equals to 60 minutes, it simply means that we can subtract, 60 minutes from this 109. It will make 1 degree. So it means that we are going to have 27 degrees here. Then when we subtract the 60 minutes here, when we subtract the 60 minutes from the 109, we are going to remain with 49 minutes. Then it will be 49 minutes west of true north. Don't forget, 1 degree, it equals to 60 minutes. So because 1 degree is equals to 60 minutes, we subtract 60 minutes from this 109 in order to add this side and have 27 degrees. Then when you subtract the 60 minutes, because they make one degree, then you will remain with 49 minutes. And then our final answer will be 27 degrees 49 minutes west of true north. We only do this when the minutes exceed 60. But if the minutes do not exceed 60, we just leave it like that. But if they exceed 60, we have to subtract the 60 minutes because they make 1 degree, and then they will increase the degrees that we have this side. So this is how we calculate the magnetic declination. Well, I hope you have enjoyed the lesson. I hope you understand now how to calculate the mean magnetic declination when we are given this information from the map. Please, kindly reminder, don't forget to like and subscribe to my channel.